All right, module 3, problem formulation. Okay, so this is the first stage. So we got a little taste of SageMaker just now doing the lab. Main takeaway was just like in general, like this is how you manipulate and run notebooks. I will actually show you on day 4 the studio setup, so you can actually see that running in an environment. General recommendation is that you're going to run your notebooks inside of a studio setup or some other kind of ML kind of IDE slash interface, right? Not as raw like we're doing now, although it's really good to run them raw just to see like how it can be done. So let's talk about this module. So we're going to talk about defining the problem. I'm not going to do a SageMaker ground truth demo now. I will definitely do one tomorrow, but I'm not going to do one today. There seems to be some errors with the API that's been kicking out. So I actually just tried to set it up and it threw a bunch of errors at me. So I'm going to come back around to it. But I promise I'll show you a SageMaker ground truth demo. You will be underwhelmed because I'm going to make the request and it's going to take a few hours and then you get an output in an S3 bucket. But regardless, I'll show you how it's done. So we're going to talk about defining the problem, choosing your data, right? Identifying success, a little bit of a summary. And then we're probably going to stop pretty much at 4:30. I'm going to leave you with the links for the problem formulation exercise and the project work. So you can take a run at that later if you want to, but we're going to make some time in the morning to do it as well for the first 30 minutes of class. So when you come in at 8:30 tomorrow morning, just be forewarned, it might be super quiet because people are going to be working on their problem formulation exercises and then doing their project work. So you're going to practice doing problem formulation with a series of problems first, and then you're going to do it for your project. It's not going to be graded. The whole idea here, though, is for you to get your kind of problem solving, kind of ML problem solving juices flowing as it relates to coming up with, success criteria, sourcing data, how you massage your data, including some feature engineering, right, at the pre-processing level. Because tomorrow, after you do your problem formulation, we're going to go right into pre-processing, and you're going to have a pre-processing lab. We're going to talk about pandas and scikit-learn and Seaborn and Matplotlib and all that. Okay. So just beware. Most of the problem formulation work is going to be done tomorrow. Okay, so let's define the business problem. So your first step really in this phase is just to define the problem you're trying to solve. Many times that's about talking to the domain experts. By the way, for those of you who work in this industry regularly, I'm just kind of curious. I don't get business problems. What I get is business solutions. Right? People come up and they're like, what was the one I got the other day? Well, first of all, I got a screenshot of a spreadsheet instead of actually getting the CSV file. And what was it? They were like, we know for a fact that 80% of customers always buy this brand, and so we want to make recommendations for this brand for customers who auto. It was something like super specific, and I was like, do you actually want me to look at do you want the team to look at the data, or do you just want us to hard code a rule? Because if you just want a rule, you can just put that in with the team and they can just hard code that up. I'm just curious. Yeah, that's the other statement, Daniel, that I always get. It's like, well, I want you guys to just make this happen. And it's like, what do you want? And it's like, I want you to predict blah, 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 or can I use it for future stock pricing? Or, if I get an amalgam of the entire like customer profile and, but I want to go fringy on it. Can I get like edge cases for like items that they might buy or are more likely to buy, but they're not in their core set based on the history? And I'm like, okay, you want me to look for anomaly patterns in their buying and suggest anomalies to them? Is that more likely to increase your bottom line, or is this just a thought experiment? Like those kind of things that I get. I'm like, I thought you wanted to increase revenue. Yes. Do you want to go with something that has an 80 or 90% probability of them buying, or do you want to go with something that was like something they bought on a fringe because it was actually for their kid or a relative and it doesn't have a high dollar value? It's like, anyway. I'm just curious how people get problems. Bottom line, your job is to help them define the business problem that they're trying to solve. I just want to be clear though, sometimes you just have to do what they ask, right? I know that a lot of you know what I'm talking about. You know that what they're asking for isn't necessarily going to drive revenue, but they're just giving you the problem they're trying to solve, and it's really narrow. So just know that sometimes you're just going to do your best with the problem that you've been given. Okay. So like in this particular case, inaccurate demand prediction is losing the company money. That could be true, right? We have unsold inventory, we've missed sales opportunities. Or one of my favorite questions is, what if everyone who has ever bought from you was still a customer? Right? What if everyone who had ever bought from you in the history of your sales was a customer, things like that. So what you're looking for in this business goal or outcome is you're looking to define the specific business problem that we're trying to solve. And so now what they're saying is that we're missing opportunities, but we're also keeping inventory that's either growing stale or is just sitting there, right? And especially as things evolve into 3D printing, keeping unsold inventory may not be the best thing. So we want to move from qualitative statements like this, right? Where it's like, look, business problem is that we're missing opportunities because we're not making good predictions, either in terms of how we are stocking shelves, but also in terms of how we are making this available to customers. And so our goal is that we want to keep unsold inventory and miss sales low. That's what we're shooting for. We don't want to keep a lot of inventory, and we actually don't want to miss sales because we're not making cogent recommendations to our customers. So how do we define success? Like what is the metric if that's the goal? Like how would we know that we had achieved the goal of not missing sales and keeping inventory low? That's really the question. And so the success metric here is at the end of each month, I want to have no more than 15% unsold inventory. And you could get deep on that and say net from the last time I ordered, total, right? And I also don't want to run out, because what if somebody orders something and I'm out of inventory? Because if you wanted to solve that problem, you could just keep no inventory, but then you would miss sales because you didn't have what the customer was looking for. So what if we could make it so that we had no more than 15% unsold inventory without running out? Now you might say, but Michael, to keep 15 out of 100 units on our shelves, that seems high. But what if they were keeping 80 before, or 60, right? Remember, the job, from my perspective, of any application or technology is just to make the situation better, right? It doesn't have to be perfect. If we could accurately predict 100 units and sell 99 of those and get them down to one inventory, that would be awesome. But the reality is that we can't always influence how and when people buy, even with the predictions and the historical data that we have, right? So bottom line, you got a business problem, there's a business goal, and there's a business success metric. Notice I said business, 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 right? So in this case, at the end of the month, no more than 15% unsold inventory. So then we come into this pivot point. What's the actual ML problem, right? It's time to decide, for example, what ML problem we're going to use. What output do we want to see from the model? Well, we got to be very specific, right? It should be a statement that reflects what an ML model could actually output, right? So what kind of machine learning are we looking for? If we, for example, want to predict a specific sales value for an item over a period of time, what will we use for that? Give me some thoughts. First of all, is this a categorical problem or is this a number problem? Just to throw that out there. Yeah. It could be a number problem. It could also be a categorical problem with numbers underneath it, right? We could say, hey, am I going to sell 100 units of this? Am I going to sell 500 units of this? I still think that we're still looking more at a numerical problem, right? So it's most likely a regression problem in this particular case. There was some thought that was tickling me here about doing a time series based regression problem, but I don't remember what it was. I'm sure it'll come back to me. So So in this particular case, it's most likely we're going to be forecasting a number based on past numbers, right? Now, what if we wanted to determine whether or not we should carry a product at all? Are we actually going to sell this? Are there any customers in our client base who would actually buy this product? Yes or no? Or would buy that? We have enough customers historically in our customer base to analyze whether or not we're going to have 100 units of sale, or like I said, 500 or 1,000, right? So you could twist it if you wanted to look at it from a different way. You also might change the prediction. Instead of looking at like a threshold and say, hey, we're going to sell 100, 500, 1,000, you might say, look, which month would it be best to put this particular product on sale? So out of the 12, right, which month would be best for us in a Gregorian calendar? So you need to classify whether it's January or maybe it's quarter. You're like, hey, should we put it on Q1, Q2, Q3, or Q4? Should we put it on in the summer? Should we put it on in the winter? Should we put it on when the temperatures are, 80 degrees consistently? Obviously, that would be more seasonality. So we don't need to make it that complicated, right? Anyway, there's a bunch of ways to approach that. But depending on how you want to approach the problem, you have multiple ML ways that you could solve this, right? Now, we are talking mainly supervised because we are going to use historical data that's labeled with outcomes. There are other ways to solve this. Now, you also don't want to overcomplicate the problem. What is the simplest and shortest path to get the data to drive the success metric, the business success metric? Right? So, because remember, if we're only trying to get 15% inventory, and let's say currently we're at 60, then we only need to improve, right, by a certain percentage. And so your ML model might say, look, for 80% of our products, we want to be able to get to, 75% certainty or 80% certainty, maybe higher, that this is the accuracy, for example, of our prediction. We know that hammers, we're going to need to carry, we have forecasted that, we're going to need to carry 89 units, and we can have, some, oh my God, my brain, we can have some, wiggle room of like plus or minus 10 units, plus or minus 15 units or so. So you want to frame your ML problem as specifically as you can, but try not to overcomplicate it, right? You want to make sure you're answering the question of, does this contribute to our measure of success? Does it support the goal? Does it solve the business problem? Now, the other thing is that, what about choosing data? How much data do you have? Where is it? Do you have access to that data, right? So let's think about the credit card fraud problem, right? What data do we actually need to train the model, right? We need data that shows what good transactions look like, and we need data to show what fraudulent transactions look like. Do we have it? Is it in the right format, right? And then, we have to talk a little bit about the typical elements that make up a data set as well, right? So, but you might need to get a domain expert. Do you have the data that you need? Is the data representative? Do you need to contextualize the data in some form or fashion? Do you need to talk to somebody else who will tell us, hey, by the way, will this data tell us what we need to know about the domain in question? So it's like, what data do we actually need to train our models to reach the desired output? Not just the label data, but also the feature data. What is that? So, one thing that I often see happen is that sometimes, because we are engineers, right, and we are scientists, and we understand how this process works, we won't necessarily pull in domain experts to contextualize and verify our statements and assumptions. Sometimes you don't have a domain expert, just to be frank about it. So, yeah. So again, if you want to do fraudulent data as an example, make sure that you have the positive and a negative data set, right? So it can distinguish with the two types. Like I said, if your average like positive, like this is fraud data set is like, 5%, 1%, 3%, something along those lines, and of your total data set, that's only 1 or 3 or 5%, that might be hard for your model to figure out what fraudulent transactions look like. It's going to be really good at figuring out what non-fraudulent transactions look like. So just remember that you have enough, like when you examine, like, do we have the data? Does it have enough of the like positive label that you're going for as part of the overall data set? So just things you have to evaluate. You also need to look at the quality of the data. Remember, you want the features of your data set to like give some kind of signal or meaning or weight to the outcome that you're looking for, right? So if you're trying to forecast, for example, sales, especially as it relates to inventory, right? Joel, I gotta tell you, in my experience, generally 50-50 data sets tend to work pretty well. There, I've seen edge cases where like 60-40, 70-30 tend to work well, but frankly, 50-50, especially if you're doing binary classification, that's ideal, right? Because you're trying to train it. It also depends on how large the data set is, but for the most part, ideally you would get 50-50 on positive and negatives, right? Yeah. Yeah, thank you for calling that out. Let's see, features and labels you already have. Okay, yeah, so like for example, in the fraudulent transaction setup, it's like a feature, by the way, that is the outcome that you're trying to predict is typically called a label. But it's just a characteristic of your data, but it just so happens that this characteristic is the prediction somewhere, right? We know that when someone called in and they bought a Kindle in the last 90 days, blah, 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 whatever like characteristic you want to call out, and they got directly to the right agent. In other words, did they, like in the previous example with Amazon, it's like, was the call transferred 0 times? Did they start out with the right agent, or was the call transferred 1 or more times? Remember, that was a multi-class problem because we were trying to figure out what department to get them to reduce the number of transfers. But that's the thing we were trying to like get down, is that did we get them to the right department? Yes, they ended up in the right department the first time. They ended up in accounting. These people ended up with the Kindle team. These people ended up with the Echo team. Did they end up in the right place? There's a label on that data set that basically says, maybe there's 2, but 1 usually, right? This is the department they ended up in, and there were 0 call transfers, right? So remember, data for which you know the prediction or the outcome based on the other features of the data, remember that's labeled data. The label is the answer that you want to predict. So this fraud, not fraud is a perfect example. A feature is just an attribute of the data set that can be used to identify the patterns. Do you need a lot of labeled data? I don't even know what that question means. Yes, the answer is yes. But quote Sherlock Holmes, data, data, data. I cannot make bricks without clay, right? So it also depends on what the context of your problem, right? Obviously things like autonomous driving or doing like behavior analytics, there can be such a thing as too much data because it's just like noise, right? But is it relevant data, right? Of course. And I think I mentioned this before. Remember that ground truth, you can use a combination of unsupervised modeling, which will then generate labels, plus human beings who will label it. Do not forget that you can use Mechanical Turk, a public workforce. You can use your own private workforce, which is like can be internal to your company, and of course you could use your own third party if you have a relationship. So ground truth is going to give you access to a team of human labelers that are going to label your data and then feed that label data back to the service for automatic labeling. Maybe. Can we check the data that SageMaker assigned to humans to label? Yes, definitely. Jeffrey, yeah. After they label, absolutely. let's see. Talk about ground using machine learning to produce an accurate training data set. Yes, and you can check the data set after it's labeled, of course. By the way, when you submit ground truth, depending on what kind of labeling you're asking for, just know that they're going to ask you for good examples and they're going to ask you for a bad example, right? For example, if you wanted to put a bounding box, like what did we do the other day? I was doing something with my son and we were submitting a bunch of dragon pictures and he wanted to identify dragons. We were putting bounding boxes around dragon faces. And so we gave it one where it was like, these are dragons. These are not dragons, right? So we were like we were labeling a bunch of like Dungeons. He plays Dungeons and Dragons. We were labeling a bunch of dragon pictures. If ground truth can predict labels to create more labeled data for me, hasn't it already created the model to develop? No, because it requires human beings in order to label the data. So it's actually not learning the rules. It's just learning how the humans did it, right? And then creating the label just for the data set, right? So it's not actually training a model that then gets shared with you, right? It's just purely for labeling purposes. So it's doing like object recognition and confirmation. Yeah, Rachel, producing it, just labeling the data set so that you can actually get to the label in question is not a full train of the model, right? Because they're using human beings to leverage that. You're not going to do that when you train your model, right? You're just coming up, you're trying to get to make sure the data set is consistently labeled, right? For training purposes. But they're not training a model. They're leveraging human beings to do a good portion of the labeling work. And then all that's happening is that SageMaker is just mimicking what the human beings are doing, right? And you might think, well, doesn't that train a model? But it's not the same thing because the model hasn't actually learned how to do it, right? It's just mimicking the rules that were applied by the human beings. That's all. And so, I know that sounds remarkably similar, but it's not, right? The data sets that are being trained when you actually fully train a model, there's no human intervention there. That's right. We already talked about that. We already talked about the publicly credited workforce. That's Mechanical Turk, by the way, which is like 500,000 independent contractors worldwide. It's like a public crowdsourcing. That's all it really is, right? And they'll do a lot of your labeling tasks, and stuff will be publicly accessible. It will not be confidential. So don't share anything that you even consider remotely sensitive. Having people have a bunch of Dungeons and Dragons pictures didn't really matter to me, right? Private workforce or pre-approved third-party vendors are also options. Remember, the marketplace, you will find people who specialize in security if you'd rather do that. Okay, so this is all about getting a workable data set that we can use to train our model. So then how do we know that we're doing it right? Right? Now, we've already defined business goal metrics, right? Because we had a business problem, which led to a goal, which then led to some business success metrics. And then we got some model performance metrics, right? But how do we know that we're actually achieving it, right? So this is during the testing and evaluation or testing and validation sections of the pipelines. We're going to dive into this a whole lot more. So we're not going to like get deep into this, but typically there's going to be some kind of metric, like how accurate is the model? Are we minimizing false positives? Are we minimizing false negatives? Right? Is there a hybridized way of looking at this? Do we want to, look at the like probability curve and calculate the mean underneath it? There's a couple things we can look at, right? So, for example, you could say, like verbally, it's like I need the model to accurately identify at least 3/4 of the fraudulent transactions in the test data set, right? Because that's really what the test data, like the holdout data, not the valuation or the validation or evaluation data is for, is that how can we verify that our trained model, after doing all the corrections, is going to meet our business needs? typically the test data is unlabeled data. Well, rephrase that. It has labels in it because obviously you need to know whether it was successful or not. But you're trying to train it to see without the labels if it can actually get to some level of accuracy. So in addition, you're going to want to keep up on whether there's like conceptual drift, like some kind of change happening after the model is deployed, because you want to see how it performs in the real world, right? So, business goal metrics are continually like, hey, are we seeing inventory go down, but missed sales opportunities go up? Are we identifying the 3/4 or more of fraudulent transactions that we were looking for? Yeah, I love that. You can identify an inappropriate model performance metric. That's true. Like, how well is it doing in the real world? If, by the way, you go to work it and, you get it into production and all of a sudden you start seeing accuracy go down, it's probably because it needs to be retrained with new data, because something has changed about the data reality versus its predictive reality, right? So you could, for example, you could look to see that if after 6 months, we should have at least 50% fewer customers who cancel their cards due to fraudulent transactions, or, we've caught, like I said, 75% or more of all fraudulent transactions. It just depends on kind of what the original kind of business goal was actually. Like, what is going to be the success metric there? Oh, good. Actually, we'll probably go ahead and hop into this now. So, summary. First step in the problem formulation phase, business, right? Let's define the business problem. Probably need to talk to domain experts. You're not always going to get a clean business problem. That happens. Second is, how do we, once we've got a business problem with a business goal and a business metric, how do we then figure out what ML like method we're going to look at, we're going to use, and what data do we have available to support whatever method we're going to use? If we don't have historical data, by the way, depending on the nature of the problem, we might need to go to either unsupervised or neural network methods, like more deep learning methods, to like try and figure some things out. But data is the new oil, so it's going to be harder without data to actually derive anything. That's what you need, right? You need the raw shaping material of data to be able to make predictions. No data, no predictions. So things like, how much data do you have? Where is it located? Is it accessible? Is it in the right format? Is it representative of the problem you're trying to solve? Is it got huge gaps? If 20% of the data has gaps, that might not be a problem, right? Depending on the size of the data set. If 50% or more of the data set has gaps, that could be a problem, especially if you can't do any kind of meaningful imputation to fill in the holes, right? If most of the data is of a negative outcome and you need more of a 50-50 split, again, based on the size of the data, if you have 1 million records, as an example, and only 50,000 of them are fraudulent transactions, you could reduce the number of fraudulent transactions in the data set in order to get that to be a more even number. If you needed to get closer to a 50-50 split, there's also other techniques you can use to kind of make that 50,000 positive transactions a little bit more significant. So you do want to evaluate the business goal metrics after the model has been deployed to see if it's actually meeting, for example, the business goal that you defined and solving the business problem. Okay. Questions about this phase?
Taking the example of the fraudulent transactions, the balance of your classes, does that only matter? Does it only matter if you are doing like a row level binary classification problem, like saying an individual transaction is is fraud or is not fraud? Because the like wouldn't you be able to reframe it to like, let me do anomaly detection, or let me do some like graphical analysis, which I think is what banks do, to say like all of the features in this transaction, as compared to other features of other transactions, indicate that this might be fraud.
Right. In other words, you're saying like, what if you couldn't get to a 50-50 or 60-40 data split and you only had a small percentage? Could we still use that data in an unsupervised manner to like look for anomalies that are outside of common clusters for commonly normal transactions? Is that what you're asking?
Basically, yeah.
Yeah, absolutely. That's why I think when doing the problem formulation, you can frame it in whatever way you need to according to the data that you have, right? So yeah, absolutely. You could look at it that way. And I think anomaly detection is probably a more common method for detecting fraudulent, like for example, anomalies in general than using supervised data, but I think it depends on what
Yeah,
you.
I guess that's kind of why I'm asking, because in all of this, the fraud detection example um, is often categorized as a binary classification problem, and it seems to me like the easier way, and often in the context of like, you have unbalanced classes, what do you do? It seems like the balance wouldn't matter if you just turned it into an unsupervised learning.
I would say though, Angela, I'm not sure that would be the easier way per se, right? If you have an unbalanced class and you're forced to do that, absolutely. But you will get more certainty with a supervised data set typically than you will with an unsupervised data set. Again, that's a big statement. But again, just because it's anomaly doesn't necessarily mean that it's a fraudulent transaction, especially when it comes to like, for example, human behavior, right? People go off the wire all the time. Does that mean that every transaction that's anomalous, like then how do you qualify it at that point in time? Then you have to look at other characteristics. So supervised data tends to offer a little bit more certainty in those kind of arenas from a behavioral standpoint than unsupervised data, because you can identify that it's an anomaly, but just because it's an anomaly doesn't mean it's fraudulent. Like sometimes it requires a little bit of a deeper dive. But if you're forced to, it's totally a valid way to solve the problem. But supervised tends to offer a little bit more certainty, especially when it comes to behavioral, right? Problems. So we're still back to kind of, and it depends, but you're totally right. You can use that to solve the issue. Yeah, because I don't know many companies that, we have a 50-50 split on this for like fraudulent transactions as an example. Usually they're anomalies, they're not core. Okay. Other questions? Okay, so next step is a hands-on exercise. Wow, that's pretty fast. All right, here's what we're going to do is that we're going to spend some time for you to just run through the business scenario. I'm actually going to share the link because this is actually at the point in time where you would actually choose your project, but we're going to save this second part for the morning. This first part where we're actually just you're going to run through like there's 4 business scenarios. One of them's already filled out. We're just going to spend the next like 30 minutes or so going through it. Let me share the link with you. Let's talk about what this is. Let's see. So I'm going to share with you the first link, which is the problem formulation. This is a Word doc that you can download. Hey, look at that. So this is a problem formulation doc, right? That basically allows you to practice answering these 4 questions. Now, this is very high level, and this is really just meant to get your kind of juices flowing around the concept. I will mention that there's also a solutions document that gives you an example that you can also refer to that this basically shows like it all filled out. Like if you want to like see like what Amazon would, how they would answer these questions. Okay. So here's what we're gonna do for the next 30 minutes. Is that what I want you to do is I want you to take that first link, not the second one, the first one, and I want you to just kind of read through everything. And then you've got the following like 4 practice examples, right? Which is going to answer these 4 questions. Is machine learning appropriate for the problem? What is the ML problem if there is one? What kind of ML problem is this? And is the data that's being suggested appropriate? Now, I'm going to forewarn you, you're going to have to infer in some cases that data is available based on the very short statements they make. Obviously, if you were talking to a human being, you would dig into this a little bit. What data do you have? Can I see it? Can you share it with me? Can we talk about what's there? Can you send me like all the rows and columns and maybe a sample data set? Like that kind of thing. So the first scenarios will have been done for you, and the others you can fill out. The second link is an answer where the other 3 are filled in. So what I want you to do is just take a moment and kind of run through this, and we'll run through this first set together just to kind of make sure that we're talking about the same thing. So here in this one, Amazon has recently begun advertising to its customers when they visit the company website. The director in charge wants the advertisements to be as tailored, basically personalized as possible for the customer. You will have access to all of the data from the retail webpage as well as all of the customer data. That sounds fabulous. Yes, yes to that. So the first question is machine learning appropriate for the problem? Well, considering that Amazon probably has hundreds of millions of customers on their website at any given time, and you're going to get access to all of the customer data, yeah, that sounds like a scale that ML would definitely want to tackle. So that sounds pretty good. 2, what is the ML problem if there is one, and what would a possible success metric look like? Well, you know, the ML problem is that ads are not useful for customers is a wasted opportunity. Now, let's be clear also, people get freaked out when you really personalize them really well and you send stuff to them that they just talked about, but we're not doing that here. So we're okay because we're not going to collect the echo data, right? But if we don't serve ads, by the way, that's also a wasted opportunity. So either way we fall, whether we, you know, don't serve any ads or we serve ads that are not going to be bought against, we're wasting money either way, either opportunity or actual cash. So how Amazon serves the most relevant advertisements to its retail customers, how do we do that? So a success metric would look like the purchase of the product that would be advertised. Now, someone asked me, by the way, in the last classes, they're like, how would we know that the customer actually liked it? Well, if they purchase it, I'm going to assume that they liked the product that they saw because they actually follow through on purchasing it. So I think that's a good success metric. If the ad's relevant, the consumer will at least click on it and possibly purchase it. If they just ignore it, then, you know, we know we failed, right? Now, what kind of ML problem is this? Now, in this case, it's going to be basically supervised, because we have all the data from the retail website plus the customer's purchasing history. So we know whether we've shown them an ad and whether that led to a purchase. That's our success metric. That's what we're looking for. How do we know that? Of course not. I'm inferring. I don't know. I'm assuming that in the customer history data, it shows their purchases. I'm assuming on the retail website, we know whether or not we've shown a customer an ad or not. Now, do we have linkages between those two? Between the customer profile on the back end and the advertising profile on the front end? That could be a problem, but we're going to table that for now. This data is appropriate because this is the other question, right? Is this data appropriate? I would say this data is appropriate, but I just called out one potential problem is that do we have linkages between the customer historical data from purchasing versus the advertising profile data that we probably have on the front end? Now, I know for a fact Amazon solved this because I actually asked them, right? But just so you know, most online advertisers do have a fingerprinting ID for people. I know most of us are horrified to hear that. I knew I was. That lets us link back to, you know, what we're seeing on all of their devices versus what they're doing on the back end, right? As far as purchasing goes. So that's what you would do for the next 3 sets. So this one's about streamers, right? This one's about a headphone manufacturer. and this one's about a leading rideshare company. So what we're going to do is we're going to give you a second to run through this. It's 4:02 right now, so let's give you about maybe 20 or 25 minutes. And then what we're going to do is that you can type up your answers if you want to, or just keep them fresh in your head. In the morning, we're going to run through all of the answers just to make sure that we're having a cogent conversation. And then we're going to let you do this exact same thing, but just to say this, it's going to be for your project. And if you missed this post earlier, this is your student template that I posted earlier. This particular one, right? Depending on which problem you're going to solve, whether it's flight delay or recommendation engine or fraud detection, this is where we're going to answer like these particular problems. You're going to work on your project just a little bit. This is all for you. Okay. So for right now, don't worry about the student template. We're going to focus exclusively on this first link, the very top one that I posted at 3:57. And you're going to work through these problems and we're going to talk about them. If we have time, we'll do it today, but most likely we're going to do it tomorrow because we only got 27 minutes left. Okay. Questions about what we're doing for the next 30 minutes? Okay, let's get it. At 4:30, I'll check back in. I'm not going anywhere. I'll be here.